Alright everybody, welcome to the notes on 4-5. Before we start, this would be good review for some of us. If you're okay with this stuff, then you'll be fine. But I just wanted to touch on it real quick. Just a reminder of how to simplify radicals. We do this in Algebra 1 and Geometry and AFDA, but just a quick reminder because we don't do a lot of it. Okay, so the square root of 50 is equal to the square root of 25 times the square root of 2, so we can simplify that and just say that it's 5 times the square root of 2. When you do that, what you're doing right here with this square root of 50 part, when we break that up, you're looking for the largest perfect square that goes into it. Over here, we need to understand that the square root of 5/11 is the same as the square root of 5 over the square root of 11, and then we do what's called rationalize the denominator. That's when we multiply the numerator and the denominator by the denominator so that there's no radical on the bottom. All right. So a couple little reminders there. There's some practice here on those kind of problems. If you need more help with that, let me know. We can work on this either in Flex or after school. All right. So let's take a look at Chapter 4, Section 5. We're going to graph we're going to solve quadratic equations by factoring and by graphing. All right. We need to understand that wherever the graph of the function intersects the x-axis, that's a zero of the function. Okay, a zero of the function. And when we talk about this stuff in Algebra 1, we refer to zeros, roots, x-intercepts, and solutions, and those all mean the same thing. Okay, zeros, roots, x-intercepts, and solutions, all the same thing. Okay, so that's important to remember. The zero product property is something that you just may not realize it, but we use it when we're solving by factoring, and that is the understanding that anything times 0 is 0. So if I tell you that a times b, right here, if a times b equals 0, then either a is 0 or b is 0. We don't know which one. Okay, so we have to account for both. All right. So let's take a look. When we have a quadratic, and some of this will be review stuff, some of this will be a little bit new. Let's start with right here, just a relatively simple one. What are the solutions of the quadratic equation x squared minus 5x plus 6 equals 0? Okay, so same thing we did when we factored in 4-4, except for now we have this equal sign here. So all we're saying is when we get to this factored part, x minus 2 and x minus 3 equals 0, is that for this to be true, one of them has to be 0. This one could be 0, or this one could be 0. We're not sure which, so we solve for both. So x equals 2 and x equals 3. That's what would make that value 0. Okay? So if we look here, what are the solutions of the quadratic equation? Step 1 is we got to get it equal to 0. Okay? We want it equal to 0. So for this one, we would add 12 to both sides. All right? We would add 12 to both sides. Let's throw this on a new page so we can see everything. So we add 12 to both sides, and we have x squared minus 7x plus 12 equals 0. Then I'm going to factor, okay? And the only way to get x squared is x times x. Minus plus means minus minus, and then it's 4 and 3. They add up to 7. Then from here, I'm going to set each one of those equal to 0. Now this part you might be able to do in your head, and that's fine. Okay, so do each one of those, and so x equals 4, x equals 3. Okay, so those are both my answers. So for this one, x equals 4 and x equals 3. All right. Solving a quadratic equation with tables. What are the solutions of the quadratic equation? 5x squared plus 30x plus 14 equals 2 minus 2x. Okay, so first we want to rewrite in standard form, so we got to get it equal to 0. We can use our calculator's table feature, all right, to put in numbers. We enter the equation into a TI like this, and what we do is we go to the table and we find the 0 values. All right. It's pretty simple once you put it in your calculator. In my opinion, there's an easier way. We'll do number 2 in class. Okay, so don't let me forget. We'll do number 2 in class, and we'll do it on multiple calculators so that we don't have to take up time right now. But don't let me forget to show you how to do number 2 in class. Casio and TI will walk through the steps of what buttons to push there. I think the easier way to solve a quadratic is by graphing in your graphing calculator. So you're going to put it in, and we'll do it in the Casio for right now since that's a little bit simpler. So I go into my graph menu, and I'm going to put in the equation exactly as it looks. So 2 x squared plus 7x, and then I have to get it equal to 0, so this ends up being minus 15. It's important that it's equal to 0. I draw that. You can change your view window if you want, just so that it's standard, so it looks, whatever. That way it looks like the one on the screen. And then on the Casio, you're just going to use the G solver, and you're looking for the root. Okay, so one of them is -5, and then if I hit the directional pad to go to the right one, it's 1.5, and that's it. Really simple stuff. In a TI, you have to use the calc feature, so second trace, and then you'll have to do left bound and right bound in order to find the roots, each of them. Okay, so go ahead and try this one right here. X squared plus 2x minus 24 in your calculators and see what you get. Go ahead and pause the video and get an answer for that, please. Okay, so hopefully you unpaused and you got the same thing I got. X equals -6 and x equals 4. We can use quadratics in real life scenarios. So on this one, it's looking at a quadratic formula for a frog's jump. We have to understand that the parabola mirrors the jump. Okay, so this is I like this right here in the picture. This is takeoff. This is when it's in the air. This is when it lands. So you can see how far it's gone. Nothing past this point has real world meaning because the frog is not going to jump through the earth. Okay, so we're able to use the graph to answer all sorts of questions. So it says the function here, negative 0.03x squared plus 1.6 models the path of a kicked soccer ball. The height is y, the distance is x, and the units are meters. How far does the soccer ball travel? How far does the soccer ball go? Describe a reasonable domain and range for the function. Are all the domains and ranges reasonable for real-world situations? Go ahead and pause the video here. Use your calculator, get some answers, and then we'll talk about the answers here together. Go ahead and pause your calculator now. Pause your video now. Get your calculator now. There you go. Pause and do. Go. All right, so here's what I got. 53 1/3 meters there for how far it goes. 21 1/3 meters for how high it goes. A reasonable domain and range to me was between 0 and 60 for a domain, and the range from 0 to 30. If yours is different than that, keep yours. We'll talk about it next class. For part B, no, domains and ranges are constrained by real-world limits, and so that references basically what we were talking about up here, where like the range would have to stop here because the frog isn't going to jump through the earth. Okay, that's it for the notes. Real brief, real easy. I will see you guys next time. Until then, let's see. What can I tell you? I got nothing. See ya.